Hey YouTube, welcome to my next episode on circles. Today we're going to look at tangents and normals, so let's get right into it. The first thing I want to look at is one example of intersections of lines and circles. So here we go. The line with equation y equals x plus k is a tangent to the circle with equation x squared plus y squared plus 6x minus 8y plus 17 is 0. Find two possible values of k. Now for a line to be a tangent, it means that the line meets the circle once. So we just have to find the values of k in which this line would meet this circle once. Now whenever you see the word meet or intersect, you should be thinking simultaneous equations. So we're going to replace all the y's with x plus k in the circle. So we're going to get x squared plus y squared, which is now x plus k, 6x minus 8 lots of x plus k plus 17 is 0. Expanding everything, here we're going to get x squared plus 2kx plus k squared, 6x minus 8x minus 8k plus 17 is 0. Then we've got 2x squared. Now we want to collect the like terms. So we have 2kx plus 6x minus 8x. They're all like terms because they have a coefficient of x. Now the way we collect the like terms here is what I like to do is I like to write plus, open a bracket, then we're going to factorize out x, and then you're just going to read the coefficients. So we have 2k. Now 6 minus 8 is minus 2. So if you were to expand this bracket, it's going to give you the same thing here, but with the 6x and the minus 8x simplified. Which means the rest, which is the k squared, minus 8k, and 17 are all numbers, and they just make up the last bit of the quadratic. Now the next bit is, for it to be a tangent, we have to think, how many solutions is this quadratic supposed to have? Well, we just said that a tangent meets a circle once. In this case, we're talking about a circle. So this quadratic can only have one solution, which should remind you to one of the previous episodes, which is the discriminant. What does the discriminant have to be? For one solution, it has to be 0. So we're going to state b squared minus 4ac is 0. What's b in this case? It's 2k minus 2 squared minus 4. A is 2. And we have c is k squared minus 8k plus 17 is 0. Now we're going to expand all of this. Then we collect the like terms. So we're going to have minus 4k squared minus 8k plus 64k would be minus or plus even 56k. Then we've got 4 minus 36. That's going to take us to minus 132 is 0. Then we're going to divide everything by minus 4. We're going to get k squared minus 14k. Then here we're going to get positive 33 is 0. We can factorize this. K and k is going to be 11 and 3. They're both going to have to be negative. So we get k is 11 and k is 3 for us. Hey guys, I hope you enjoyed my video. If you're new here and you want more maths content, then please consider subscribing. If you're learning something, then hit that like button. Comment down below to let me know what you want to learn next. I hope you enjoy the rest of the video. Now we get into actual tangents and normals and finding their equations. So find an equation of the tangent to the circle with this equation at the point minus 2, 5. So this reminds us of GCSEs, and one of the circle theorems is that the tangent must always meet the radius at 90 degrees. So all we need to do is find the center of the circle, find the gradient of the radius, and the tangent will have to meet that line at 90 degrees. So here we're going to get x, so we half the coefficient of x is minus 1 squared, subtract 1 squared, which is just 1, plus y, plus half the coefficient of y is 3 squared, minus 3 squared is 9, then we have minus 7 is 0. So we left with x minus 1 squared plus y plus 3 squared, minus 10 minus 17, move it to the other side, 17. Now, realistically, for this problem, we didn't actually have to go this far. You can kind of read the center by just doing completing the square bit and not really writing the rest. Now that's up to you, but I think we should just do the whole thing anyway. So the center here is 1 minus 3. So just doing a brief sketch, 1 minus 3 would be somewhere here. And the radius is just a little bit more than 4. Now this isn't a big deal, it's just a sketch. Just say it looks something like this. Minus 2, 5, just say is here. We want to know what the tangent is, right? So we know that the tangent must be 90 degrees to the radius. So all we need to do is work out the gradient of the radius and then do minus 1 over. So how do we do that? We take away the coordinates. So we have minus 2, 5. We have the center being 1 minus 3. Subtract them. Minus 2 minus 1 is minus 3. 5 minus minus 3 is 8. So the gradient of the radius would be minus 8 over 3. So the gradient of the tangent, because it meets at 90 degrees, will be the negative reciprocal. So it'll be 3/8. Then we do y minus y1. So we're going to do y minus. Now remember, we're doing the coordinate of the point minus 2, 5. So here you can't just choose any of them. So it'll be y minus 5 is the gradient, 3/8. X minus minus 2 would be x plus 2. Now we're just going to times through by 8. Then we're going to multiply in the 3. And then move everything to one side. So now how would it work with normals? So normals are actually an interesting one. So if you look at my diagram here, we just have any ordinary circle and I have a tangent line. The normal, because it's 90 degrees, must trace the radius of the circle, which means that the normal to any circle must go through its center. Yeah? So very important, you guys must remember this, that the normals meaning perpendiculars, the normals to any circle has to go through its center, which we're going to use in this next example. This is quite a cool example. I really like this question. So it says the diagram shows circles C1 and C2, which both pass through the point P, and the common tangent to the circles at P, the line L. Circle C1 has that equation. Find the coordinates of the center. So we have to do the completing square. So we're going to have x minus half the coefficient would be 1 squared. Subtract 1 squared is just 1 plus y. Then minus half the coefficient of y is just 1 squared. Subtract 1 squared is just 1. Minus 23 is 0. So we have x minus 1 squared plus y minus 1 squared. Then that would equal 25. So the center is all they're asking for is 1, 1. The circle C2 has this equation. Find an equation of the straight line passing through the center of C1 and the center of C2. So all we need to do is we need to work out what the center of C2 is. Now you don't have to go the full way here, so I'm going to kind of be tricky here in terms of not having to do as much as we usually do. So to find the center, we just need to half the coefficient of x. So we would have done x minus 4 squared. Then we would have written plus something. Then we're going to do y minus half the coefficient of y would be 5 squared plus dot dot equals something, right? Or equals 0 in this case. So the center of C2 is 4, 5. And that's all we need. We don't need the full equation. They don't care about the radius. To find the equation of the line passing through, we just don't need the radius at all. So we just need to take away the coordinates now. 4, 5 minus 1, 1. 4 minus 1, 3, 5 minus 1, 4. So the gradient then is the change in y over the change in x. Then we're going to do y minus y1. So we can pick any coordinate we want. I think 1, 1 is easier, right? So y minus 1 is 4/3 x minus 1. Times through by 3 is 4x minus 4. Then move everything to one side. Then it's just saying, what does the equation of L have to be? So this is an interesting problem because you're thinking, okay, well, we obviously need to find the point P, right? L, we can see from the diagram, goes through P. But how do we find P? Do we do simultaneous equations with the curves or the circles C1 and C2? That's going to be quite problematic. In fact, you're not going to be able to do it. Look at these two. How are you going to rearrange for one variable to cancel out the other? Taking them away, you get rid of the x squareds and the y squareds, but you'll still get one equation with x and y. So it just doesn't help. There's a trick to this. And that is what we explained before, that the perpendicular or the normal to any circle must go through their centers. So for us to have worked out where the center of C1 is, say it's here, it was 1, 1, right? And the center of C2, which is 4, 5, the normal to both circles at P must go through their centers. So what we've actually worked out is that this purple line is the equation we found in B that goes through both centers. So from there we think, okay, well then how do you work out L? Well, 90 degrees. So we know what the gradient of L is. If the gradient of the purple line was 4/3, then the gradient of L must be -3/4. Then you ask, okay, well, how do we work out P then? Well, we just find where the line intersects either C1 or C2. Yeah, you can pick whichever one you want. Which one do we want to pick? I don't know, maybe C1 just because it's there already. So to find P, we're going to do simultaneous equations. So we're going to rearrange for Y or X, whichever one. I'm just going to rearrange for Y here. Y would be plus 4X minus 1 all over 3. And now we're going to sub that in. Yeah, we're going to sub that into our circle of C1. Remember, you could have subbed it into C2 as well. So we get x squared plus y squared, square the top and the bottom, 4x minus 1 squared over 9, minus 2x minus 2 lots of y, which is 4x minus 1 over 3. And then we have minus 23 equals 0. So the first thing we want to do here is times everything by 9 to get rid of denominators. Expand everything, simplify. Now simplifying this whole quadratic, luckily here we can divide everything by 25. We get x squared minus 2x minus 8 is 0. Factorizing, we're going to have 4 and 2. So we have 4 and 2. We're going to have minus 4 plus 2. So x is 4 or minus 2. Then you've got to decide which one do we want. Well, clearly P is the negative version. Remember, we're solving where the line meets C1. So there's two solutions. There's that one and P. So we're interested in minus 2. We sub that in for Y. So we're doing 4 times minus 2. So we're subbing into here. 4 times minus 2 minus 1 over 3 is minus 3. So the coordinate of P is minus 2 minus 3. And don't forget, we said that it's gradient. So the gradient of L is the negative reciprocal of the line from part B. So that'll be minus 3/4. Now we just do y minus y1 again. So we're doing y minus minus 3 would be y plus 3 is minus 3/4 x minus minus 2 is x plus 2 times through by 4 is minus 3x minus 6. And move everything to one side. And there's our answer. So that would be regarded as quite a tough question, but when you look at the picture, you add the lines that you've been working out, it's actually not that bad. So I hope you enjoyed that, guys. That's it for now. Stay tuned for the next episode. We're going to be doing more circle properties and we're going to be applying it to some really tough exam questions. So if you learned anything, please hit that like button. And if you want more maths content, make sure you're subscribed and I'll see you guys in my next video. Peace.